least square fitting. Okay, we are almost towards the end of this unit, so with this we'll complete it. Okay, least square fitting. Sometimes what happens is when you are doing any kind of graphical representation, you get some points on the graph which are scattered. Okay, and then you actually want to assign a particular pattern to it. Okay, you want to know its behavior, and for such purposes sometimes least square fitting plays a very important role. Okay, you know, whenever you are actually plotting a point on a graph, it's not always mandatory that it should be a result without any kind of error. Okay, there are always experimental hindrances, always experimental errors which are there, based on which the points which are there might not represent the exact result. For such reasons, techniques like least square fitting, extrapolation, interpolation plays a very important role. Okay, so this is basically what we are actually trying to understand using the help of statistics. And you know, whenever you're doing any kind of characterization of your samples and you have a large number of data and you want to know what is the behavior of that data or behavior of that result. Okay, in general you are talking about the behavior of that particular material, let's say in material science, by plotting a graph. For that, these least square fitting and then understanding the distribution is very important. Okay? And that's why we are actually tackling this. So least square fitting is basically a mathematical procedure, okay, for finding. So it's basically a mathematical procedure for finding the best fit, okay, best fitting curve to a given set of points, okay, by minimizing the sum of the squares, sum of these squares. So if we are actually able to minimize the sum of the squares, okay, mathematically, and it has been seen that this will actually give you the best fit. Okay, so we are going to look into some problems. When we do a numerical problem, it will be more clear what exactly do I mean by minimizing the sum of the squares. Okay, so let's just write down the points here, which are important. Okay. It is a standard approach. Okay? It's a very standard approach to actually analyze the data for regression analysis. There is something which is called the regression analysis. I'm going to tell you what is regression analysis. Okay, so maybe you can just take this regression analysis. So these are all statistical terms that should be known to you. Okay, so it is a set of statistical processes for estimating. Okay, so you know we are estimating, and these estimates are usually quite good. Okay? Estimating the relationship between a dependent variable and one or more independent variables. So what do I exactly mean by this? Imagine you don't know what is the relation between x and y, but you have a lot of data between x and y. Let's say voltage and current. Okay, and you plot a graph. You get a straight line. Okay, that means you straight away say that this relation between x and y is linear in nature. Okay, x is directly proportional to y, and that is how it is done. Okay, so it should not be very complicated to understand. Okay, maybe I can tell you this. So let's say I don't know what is the relation between voltage and current, so I plot voltage and I take current. Okay, and let's say I've got a voltage of 2 volts, I get a current of, let's say, 1 ampere. I get a voltage of 4 volts, I get a current of 2 amperes, and then 6 volt, I get a current of 3 amperes, and so on. Okay, and then what I do, the next step is actually to plot a graph. Okay, so as I told you, I will take the independent variable along the x-axis, so that's voltage in this case, and current along the y-axis. Then what I do, I'll plot the graph. So let's say these are the points. Okay, current, and then these are the voltage points. Okay, let's say, so let's say this is 2, this is 4, this is 6, this is 1, 2, 3, and you plot the points here. You get 1 point here, you maybe 1 point here, maybe 1 point here, and then you can keep on plotting the points, and you straight away see that this is going to be a straight line. This is the fitting. This is the least square fitting that you're doing. And you, after this plotting these points and joining them, you see that this is actually a straight line. And using this straight line, you can straight away say that it has basically got a linear relationship between voltage and current. Linear relation between voltage and current. What does it say? That we are basically talking about conductor here. Okay, that means the material is a conductor. So this is the simplest of example I can give you to understand the fitting and the regression analysis part. Okay, so in a similar way, if you're actually plotting a graph and suppose you are getting you're not getting a straight line, you're getting something like this, let's say. So this is going to be basically a diode, right? This is the behavior of a diode. So depending on that, we can actually analyze what is the material. Okay, so that is what is important in these regression analysis. Okay, so there are different regression lines. Okay, the most common would be the linear regression. So this fitting that I'm doing is basically nothing but the regression analysis. So this is a linear regression. It is all something which I'm not giving it to in terms of mathematical terms. Okay, I'm just giving it to you in terms of sentences so that it's more clear. Just look into this graph. This should be more or less clear, the concept. Okay, so ordinary square compares the unique line, okay, that minimizes the sum of squared distances between the true data and that line, between the true data and that line. So the true data might be the points and the line might be this line, and this will actually minimize the sum of the squares. Okay, so when we talk about these least squares, it can be either ordinary least square or non-linear least square. Okay, so maybe I can write down this. So when we write down least squares, okay, they might be ordinary or so by ordinary I actually mean that we are talking more or less about ordinary least squares, that it is linear in nature. Okay, if there is any kind of technical problem, if you can't see the screen or something, just let me know. Okay, ordinary least square and non-linear least squares. There are two kinds of fitting. So if you just look into this curve for a diode, it's a non-linear least square. And if you just look into this, which is for a conductor, let's say, that's ordinary least square. Okay, so these are the two types of least square tissue. Okay, so having talked so much about least square, I think one numerical problem is mandatory. Okay, so let's do a problem here. Okay, I'll just take one problem, and then this concept should be more or less clear from this particular problem. Okay, the question is find the least square line, okay, for the following data and trend values. So in this particular exam that you're going to have, let's say the N7, so on, might be the mid-sem if you have it online. Probably you just need to arrange a graph for you also. In case I'm asking a question from this particular unit, the chances are that there might be some graphs that is needed. Okay, so please make sure you also arrange for a graph. 2, 3, 4, 5. Okay, and then let's say I'll just take up y value, and this would be 2, and then let's say I will take 5 and 3 and 8 and 7. Okay, so this is actually nothing but the values which are given for x and y. You have to find out the least square line for the following data. Okay, okay, the question is how do we do it? Okay, so what I'm going to do is I'm probably just going to write down a table for you. Okay, and then you're just going to look into what exactly we mean by squaring. Okay, So let's just write down this. Okay, so this is x. So just check into this table now. Okay, y, sorry, capital Y, and then we can take capital XY, and then I will take x square. Okay, then let's see what are the values that we have here. Okay, so I'm just going to write down the table, and then probably it is going to, so I will leave some space here. Okay, let's see, we have this table now. Once we have this table, what we can write down is equation of least square line. So if we are considering it to be a least square line, this is basically a straight line. Okay, so if it's an equation of least square line, the form would be y is equal to mx plus c. Okay, so we're just going to look into that. Okay, so equation of least square line, equation of least square line. Okay, so that means it is y. Okay, if you write it down, equation of least square line, y is equal to a, okay, plus bx. Okay, this is the equation of the least square line. Okay, and what we can do is, if you just want to write down the normal equation, okay, we have to just take the summation of those parts. Okay, so what we can do is, let me just use my pen here. Okay, you can just take this as summation of y, because there are a number of points here. Okay, is equal to n into a, where a is the intercept, okay, and b is the slope, we already know it, plus b summation y. It's okay, sorry, x is bx. Okay. So we have to actually find out this form first. Okay, and once we actually find out the form, we can actually write down the normal equation for b. So this is the normal equation for a. This is normal equation for a. So we can take the summation and do it. Okay, and then we are going to write down the normal equation for b. So for b, if we are using a least square fitting, we have to do it this way: x y is equal to a summation x plus b summation x square. Okay, and this is normal equation for b. Okay, normal equation for b. Now look into this. What happens here is, normal equation for a, you already have the equation of the least square. You're just going to take up all the values, add them up, and then you're going to find out this. But for b, what you have to do is, you have to multiply by x on both sides. So this is x, multiply x here, and multiply the x value here. Okay, so what we can do here is this: multiply by x on both sides. Okay, so you have to do this, and then you're going to find out the values. Okay, and then if you take this as equation 1, let's say this is equation 1 and this is equation 2. Using 1 and 2, you can solve for a and b. Using 1 and 2, solve for a and b. Now you see, I'm not plotting any kind of graph here. What happens here is that basically when you are going to write down a linear equation, you write down y is equal to a plus bx. So you know, y and x are the variables here, a and b are the constants. So basically you have to find out what is the intercept and what is the slope. So there are two unknown variables here, so you need two equations, and that is why we are doing this. This is the first equation that we have, and this is the second equation that we have, where we multiply both sides by x, and we have two equations. Then we can actually solve for what is a and b. Once we solve for a and b, we can actually fit that curve. Okay, so what I want you now to do is solve this problem. Okay, so probably I'll just going to give you around 10 minutes and solve it, and then I'll actually ask someone of one of you to please explain this. Okay, so just try solving it and then see what's your answer. Tell me the value of a and b. Okay.